guys, the goal of this demo is to get you guys more comfortable debugging in IDA. And so to do that, we're going to work with a very basic crack me. So let's just kind of get initial impressions. Just look at the strings and kind of look at the major structures in this very small program. So first off, we have a string being built on the stack, which is a little bit obnoxious. I'd much prefer these be declared into vars, but that's what the compiler chose to do. And then we see enter the password. So we can presume that this is going to print something to the command line, and then we see this fgets, it gets some input from the command line. We scroll down, we see that we have a loop right here, and inside of this loop we do have an XOR, and it looks like an XOR of interest. It isn't simply XOR clearing a register or something like that. So this could very well be our decoding loop. And then we actually have another loop down here. So if we look right here, we do have a loop going through all of this. So let's start debugging. I'm going to start by just placing a breakpoint in the first instruction in this loop. And you can tell that based on the result of this compare, we either leave our loop or continue looping. So it's very likely that this has to do with our control structures. So I'm going to place a breakpoint with F2, and then I'm going to start debugging with F9. I'm going to pass in a big string of A's. It's very easy to recognize a big string of A's sitting in memory. Even if you only have hex, that's a big string of 4 ones. And now we'll go back to our code, and we see that we are broken on this compare. So let's talk about this compare for a second. We're comparing ESP plus 5C to 12 hex. I want to know what that is in decimal, so I'm going to use the hotkey H to convert that, and we can see that is 18. Well, where else do we use this ESP plus 5C? If we look up, we can see we're moving a 0 into it, so we're initializing it to 0. And then if we look down here, we can see that we are incrementing it by 1. There are some other operations using it, and that is actually using it as an index into an array. But we only really need to see this incrementing it by 1, initializing it by 0, and then comparing it to our control to know that it's the I for our for loop in this case. So what I'm going to do is I'm going to actually place some comments. So the :/semicolon key, if you just push it, you will pop this dialog box, and you can add some comments to your code. So I'm going to say I equals 0, and you can see my comment appeared right next to that line of code. And then I'm going to click on this line of code and say I is less than or equal to 18. Now this throws some people. It actually put the comment up on this location definition. From IDA's point of view, all 3 of these lines are the same line of code, and so it's just aesthetics at that point. And then down here, I'm going to put the comment I++. So what we're really going to focus on here isn't these LEAs and moves and adds. That's those are indexing operations. If you want to play with those later, that's cool. But what we're really going to focus on is this XOR, and then how the decoded bit is written back into memory, and where that decoded byte, not bit, is written into memory. So let's F8 to step over, and we can see that 0 is in fact less than 18, so we are going to jump over here. And again, we're not going to pay too much attention to this, so I'm just going to put a breakpoint on this XOR instruction, and then hit F9 to continue down to my breakpoint. Now we're XORing AL, which it looks like it's all of these instructions. The purpose of them was to get AL into AL. And so let's see, if we come up here and hover over this ESP plus 3.1, and then I'm using the scrolly wheel on my mouse, you can see there's a big string of encoded blobbiness there, the first byte of which is 12 hex. And then if you come and look at your AL, that value is 12. So my guess, without even having to dig into this code too much, is that we're going to grab a byte from this string. These operations are going to get that byte into AL, and then it looks like we're XORing it against a constant. So ESP plus 58, which happens in this case to hold 54 hex, or the character T. So after this XOR operation occurs, that XOR is going to be done in place into AL. So AL will become 12 XOR 54. So let's pull up a calculator and do that just so that you guys, I can prove it to you guys. So I've got my programmer calculator, we're in hex. If I do 12 XOR, that was 54. That's going to equal 46. So we expect AL to be 46 when we execute this instruction. So let's execute it. F8 to step over. We'll go hover on AL, and sure enough, AL equals 46. So now again, we're not going to pay too much attention to the indexing instructions, but down here we want to see where our byte is written back into memory. So I highlight our AL, and we can see that our AL is being written into the address stored in EDX. So let's again put a breakpoint on that. F9 down to our breakpoint. And let's go to EDX in memory. So EDX is at 28FE9C. Click into memory, hit G, 28FE9C, enter, and let's watch this location. So we should expect when we move AL for a byte to appear right here, specifically 46. So F8, and sure enough, 46 is written to that location in memory, and we get an F. Now we increment our counter and come back around to our control. Now, remember, you can hover over things to see their value. Our counter holds a 1. 1 is still less than 18, so we're still going to make that jump. So let's see if our hypothesis was correct. So the first byte was 12 hex. The second byte would be 3D. So let's see if a 3D ends up in AL right here. So I'm just going to F8 until we get there. And sure enough, a 3D is in AL. We're going to be XORing that with our constant 54. The result will be stored in AL. And so our clear text byte is 69. Now we need to write our 69 back into memory down here. So let's, I'll just F8 to that point. But at this point, EDX equals 28FE9D. That is actually +1 from where we were before. And that's because some of this magic with the I. So when we write our byte, it should be written right here. So let's go ahead and do that. And you see our next byte is decoded. We increment our counter. So now when we hover over it, we can see a 2 sitting there. 2 is still less than 18. I promise I'm not going to do this 18 times. So let's go on to our XOR. I'm going to hit F9. And if our hypothesis is correct, we should have a 2-6 in AL at this point. And sure enough, there it is. We're going to XOR against our constant 54, store our plain text byte into AL. So there's our plain text byte 72. And then when we come down here, we're going to write our 72 to what is now our EDX +1. And so we should expect that to come right here. And there we go. So y'all can iterate through that as many times as you want. I do encourage you, if you have an assembly background, if you have a programming background even, do play around with these instructions and see if you can understand how this 5C is being used as an index into the string. But that is less important than understanding the XOR and the move and the control structures of the loop. So I'm going to get rid of these breakpoints, otherwise we're going to have to break in the loop every time. And I only want to know when we break out of this loop. So I'm going to put a breakpoint over here instead. that means that we are going to loop until we actually jump to the left. So we should loop our 18 times and then jump over here. So I'm going to hit F9, and sure enough, if we look down in that same location in memory, we can see the string first crack me demo. Bang. Pretty cool. And what's happening here? Well, it looks like we are reinitializing our I to equal 0. And that makes sense because, as we talked about in the beginning, there's another loop down here, and it looks like this loop is also using our ESP plus 5C to hold its counter. So if we continue down, we'll turn that into decimal, so we're doing 17 bytes this time. And so we'll add a comment, I is less than or equal to 17. And now let's see what the important components of this part are. So really this compare. It looks like we're getting a byte into DL and we're getting a byte into AL. Again, we're using this 5C as a form of index into those two arrays of characters. Don't want to overwhelm you guys with all that nonsense. What's important here is this comparison between 2 bytes that's determining the jump. So let's put a breakpoint there and see if we can figure out what's going on without having to understand this stuff. So I'm going to hit F9 to continue to my breakpoint. And that's a little dangerous, just because there's actually a decision point here. So we can put a breakpoint there too. Not that we're going to hit it because we know that 0 is less than 17, but just for grins and giggles. F9. Alright, so let's take a look at our DL. Our DL holds a 4-6. Now if you happen to remember, 4-6 was the first byte that we decoded. And what's in AL? AL holds a 4-1. This is why I pass in A's all the time, because I recognize hex 4-1. Hex 4-1 is a big string of A's. So let's also look up and see where these came from. DL looks like it came from this ESP plus 1C. And if we look there, we can see that's our plain text string. AL, we can't actually see our AL right now because we overwrote it right here when we moved this byte pointer from it. So we'll take a look at that our next iteration around. But we suspect that we have our DL is a byte of our plain text string, and based on there being a 4-1 in our AL, we suspect that's a byte of the string that was passed in. And if those don't equal each other, it looks like we're going to jump to not quite. Right? So 4-6 does not equal 4-1, and so we're going to jump to our fail case. I'm not really in the mood to do that right now, so I'm not going to. There are a few options here. What I'm going to do is just set my EIP to over here. So if we jumped to the left, our EIP would equal this address. If we jump to the right, our instruction pointer would equal this address. So I'm just going to right click, set IP. And now we're not jumping anymore. The magic of debuggers. So now we're going to loop back around up to our test of I. So I'm going to hit F8, and again you can hover over this and see that it equals 1 now. 1 is still less than 17, so we're going to drop into here again. Now this time I do want to see what this value of EAX is before we overwrite it. So I'm going to put a breakpoint right there, F2. I'm going to hit F9. And so now let's hover over this EAX as an address, and we can see that it is in fact the address that contains a whole bunch of A's. In fact, since this is the second time we've iterated through this loop, I suspect there's an A before that. So let's go take a look in memory. 28FEC7, click G, 28FEC7, is that what I said? And sure enough, the address that we're on is actually the second byte of that string that we passed in, which corresponds to our second iteration through the loop. We're 0 indexed, so that's our I equals 1. So we've got our 0 indexed second byte of our plain text key, and we've got our 0 indexed second byte of what we passed in. We're going to compare those two, and we're going to jump accordingly. And they're not going to equal each other. Sad days. Let's try a different way of making the debugger do what we want. So this jump 0 checks the 0 flag and jumps if it equals 0. We can come all the way over here to the right side of our screen and see the 0 flag declared right here. Currently does equal 0. I'm just going to double click it and set that to 1. Okay, and now magically the blinking line is going the other way. So that's another way of accomplishing the same thing that we did by setting EIP on that last iteration. So let's do that one more time. So our counter is 2 now. So 0 indexed, we're at our third byte. Our 0 indexed, we're at our second byte. Normal thinking, we're at our third byte. And I'm going to F9 to hit our breakpoint. And we can see that our third byte should be a hex 7.2. So we should have a hex 7.2 in DL. And then our third byte, it should still be a 4.1, a big string of A's. You can see that that memory address is now ending C8, whereas the last iteration it was ending C7. So we have moved to our next byte of A's, and we're going to compare the byte we passed in to the byte of the plain text. So what this is doing is checking to see that byte by byte, the byte that you passed in equals the byte of the plain text for a total of 17 bytes. So what do you think we have to pass in order to get to this point in the code without having to do all sorts of hijacky debugger shenanigans? The plain text string that we decoded. So first, crack me demo bang. So let's try that. So I'm going to terminate debugging by hitting this X up here, or sorry, the square. And actually, let's just run it in the command line. So let's learn a shortcut. If I want to pop a command line on the desktop, I can go to the desktop in File Explorer, type CMD, enter, and now I'm on the desktop. So this is crackmedemo.exe. We can see it asks for the password, and that was first capital F, crackmedemo bang, and we can see that we print you got it. Before I turn you loose, I want to show you how I would solve this if this were a question in a CTF. So first off, this would be a very low point value question in CTF, but a lot of times you'll still see it just to give newer students to reverse engineering something to work on. So approaching this in a CTF, obviously you have time pressure, so you don't want to just fool around trying to understand all the code. You want to shake the answer out as quickly as you can. So what I would do is I actually work these problems in reverse. I'd come up here and see that this way says not quite, this way says you've got it, that this jump seems to have something to do with it, and it follows a compare. I'd put a breakpoint on that compare. I'd start debugging. I always pass in A's. And then I would start looking around at the different register values at this location. So I'd click on this DL, I'd see that it seemed to be set up here, and there's your string. So in less than a minute you can shake the string out of the sample. That's the CTF way. That's the I need the answer fast way, not the let's understand the code and learn from it way. But since CTFs are a pretty common thing, I thought I'd show you that. Alright, your lab's a little bit easier than this, but it does still involve debugging, so please feel free to ask questions. I know this is a big leap for some of you guys, and that's okay. It doesn't have to feel good. It doesn't have to feel comfortable. Just start poking things. You're not going to break it. Yeah, yell if you have any questions.